All right, so this becomes important when, like all of the examples we've done so far, our diene has been, haven't been any substituents on it. We've only had substituents on, say, our dienophile. So and this would be our product. But we haven't seen anything where we've got, say, some methyl groups on our diene, and we're doing a Diels-Alder reaction here. And so when we do all of our, move the arrows around, and we write our product out, we know that these two substituents on the right-hand side here are trans. So these are trans because this is trans. But we don't know what how our methyl groups are right here, our two methyl groups. Are they up? Are they down? And so it's the endo or exo transition state, which is going to dictate, are those methyl groups up or are those methyl groups down? And in relation to the other two substituents. So that's what we're going to do today. So let's do that right now. We're going to do two relatively similar examples, and hopefully it'll dictate how this works. Okay, so yeah, let's do the endo here, exo over here. Yeah, whenever you hear a break in my talking, it's because my screen's all of a sudden gone black. It's highly irritating. Anyway, okay, so the first thing we're going to do, and let's do this last reaction, which we started right here. So let's do this reaction right here. So what I'm going to do is, in each case, I'm going to draw the diene, and I'm going to draw it ginormous here. Just really, really, really big. So the first step is to draw the diene. Then the next step is to draw the dienophile, and I'll draw this in blue just to. So the endo, the methyl group's over here, and the carbonyl is over here. And the methyl group will be over here, and the carbonyl will be over here. So those are our two transition states. Now, we need to see the relationship of that methyl group with the other substituents. So what I'm going to do next is I'm going to draw the protons on my little double bond here of the diene, right? I'm going to draw the protons. I'm going to exaggerate them. I'm going to draw them really far out and exaggerate their location. Then to determine what's on the same side, I'll draw this in red. I'm going to make a little, or green, for example. I'm just going to circle all these things. These groups are the groups on the right-hand side that are on the same side. Same side. So when we draw our product, the core part of our product's identical in each case, right? So for example, we've got our 6-membered ring. We've got our double bond. And so I'll just put the methyl groups here and I won't determine where they are yet. But we've got a trans system. So I'm just going to draw this up. I'll just draw this one up and this one down. Right? So now for each product is where we'll put the methyl group. So remember, the methyl group is here, in here, or here, and here. The protons are on the same carbon as those methyl groups. So it's the protons that are on these carbons here. So on the endo transition state, those two protons are on the same side as the methyl group. This particular methyl group right here. So if this methyl group is down, that means that those two protons have to be down, which means that the methyl groups that were there are up. And in the exo transition state, the carbonyl is on the same side as those two protons. So if the carbonyl, if we define that one as up, that means that in this transition state, the methyl groups, the little protons are up, and the two methyl groups will be down. So this is, so if you look at the two products, the endo and the exo, the relationship of the substituents, the ketone and like the relationship here and here is identical. They're both trans because they started trans. The only thing which has changed is the relationship between the two methyl groups and those substituents. So on the endo, the methyl groups are on the same side as the ketone, and on the exo, the methyl groups are on the opposite side of the ketone and on the same side as this red methyl group over here. That one. Yeah, so you need to know, like, whenever your diene itself has got some substituents on it, that's when in positions, and I guess in positions 1, 2, 3, 4, in positions 1 and 4, that's when you need to use to determine if is it an endo transition state or is it an exo transition state. Let's do a couple more examples and everyone will get the gist of it. Okay, so let's do this reaction. So remember, when a diene is locked in that cis conformation, it is very reactive. So this diene right here is one of the most reactive dienes there is. It's so reactive, it actually reacts with itself. And to use it, you have to do a reverse Diels-Alder reaction to make it so it can react with something else. But anyway, that's fun stuff for upper year course. This is, let's do the mechanism here. And let's draw the product. Okay, so we form a 6-membered ring. One, two, three, four, A, B. 1, 2, 3, 4, A, B. Okay, so we're going to put on our substituents here. On B, we've got a ketone. On A, we've got a methyl group. I've made them trans because we know that they're going to be trans. Between carbon 2 and 3, we have got a double bond. Now, the thing which is new here is that we've got a carbon, which I will call 5, right here. And so carbons, both carbons 1 and carbon 4 are bonded to carbon 5. So it would look like this. So that little carbon 5 here, it could be up or it could be down. Is it a wedge line or is it a dash line? And so whether or not this reaction is exo or endo is going to tell us, is carbon 5 going up or is it coming down? Right now, I've just tried to draw it flat. So we will do this. Endo, exo. All right, so let's, first things first is we'll draw our diene and we'll draw it really, really big. Diene. Draw it really, really big. And then we need to draw our dienophile. The endo transition state, the carbonyl is underneath, and on the exo, the carbonyl is on the exterior. Now, we don't need to draw the protons on like we did last time because we've got that bridging carbon, which is drawn in its place. That's why I made it really long. And so if we circle the things that are on the right-hand side here, in the endo transition state, you'll see that the bridge is on the same side as the methyl group. And on the exo, it is the carbonyl, which is on the same side as the bridge. So our two products will look like this. So they're on this one's on the same side as the methyl group. So that will be down. Come on, computer, quit being. So now it's on the same side, so I'll make this a line pointing up. So the methyl group and the bridge are on the same side, in this case on the left. So that's down, same side. And in this case, the bridge and the carbonyl are on the same side. So this would be the exo. Come on, computer.